how to do it.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor.
Teach me how to factor. Teach me how to factor. Teach me how to factor. Teach me how to factor.
Everybody factor. Everybody factor. Everybody factor. Check my work when I factor.
All right, well, welcome back, Algebra 1 students. So here we go, 7.8 in our Big Ideas curriculum. This is our last section on factoring, and we're factoring polynomials completely, it says here. We're actually learning one more method of factoring, and then we'll be really looking at factoring the polynomials completely. So we've learned how to factor some special two terms, some special binomials when there are two terms. We learned how to factor the trinomials, the three terms, sometimes when there is just an x squared or nothing in front, no number in front of x squared. Sometimes when there's a number in front of x squared, which makes it a little more difficult with the star method. So we learned simple method, star method with those. And now we come to a four-term polynomial. That's what we're going to look at. Factoring polynomials by grouping is when we have four terms. And so we'll look at that first, and then we'll go into factoring polynomials completely. But let's start with our cartoon. So here's a far side cartoon, an artist painting a picture. It looks like a cow. It's from the body style, but then he says the curse of artist block. You can't figure out what head to put on the cow. Alligator head, rhinoceros head. I can't think of what's supposed to go on the top of this thing. All right, well, let's move on into our factoring by grouping. So this is where we'll start. This is our new one, so here you can see what they look like. There's four terms in the polynomial. There's three steps that we're going to look at here, and I kind of numbered them. You have this on page 241 in your journal book, and you can just kind of do that for four terms. When you do have four terms, you're going to first, number one, group the terms into two pairs. So now you got to figure out which two pairs should you group. So looking at like letter A right here, we would see that letter A is a trinomial. It's in standard form. It only has just x's in it, so it's got the x to the third, x squared, x in a constant number. That's the standard form, and so if that's in standard form like that, then the grouping is very easy. We can just group the first two right there, just those two, and then group the second two. You can put a line between them if you want to, or something like that. But you're just going to group the first two, group the second two. But when we look at this one, where there's just only letters, there's no numbers really, no coefficient numbers. You have some x's and some y's. We would need to figure out, okay, which ones do we want to group here? Which ones should we group? We really should put the y ones together. So we really should put the x squared first here, and then this x should come over. So group it like that. Those two should group together. And then we should group these ones with the y. So we should put the y and then the xy. And you can do the xy, or you could do it the other way around. You could put the xy first, then the x. But those ones should be grouping together too, because you have y's here that would come. There's something in common between those with the y's. There's something in common here with just x's. So that's why we can do something like that. And then it says factor the GCF. So we'd want to factor the GCF out of the two groups. So out of this group right here, we'd want to look for what's the GCF. That would be an x squared would come out, and then what would be left on this one would be just an x from the first term and then a 3. And so we're looking for that there. We do the same thing here, factor out the GCF of this group. That would be a 2. 2 could come out of this group, and then we have an x, and then 2 comes out of 6. That would be a 3. And so then we would look at the final thing there, step number 3. We look for and factor out the common binomial factors. So we're looking for a matching binomial, basically. Right here is a matching binomial with x plus 3. That would be one of the factors in our answer. So we'd say like x plus 3 is a factor in the answer. And then what we factored out here, the x squared and then the 2, is the other factor. We would say x squared and then plus 2. Because it would be a positive 2 here. This is a big positive in the middle between the two factors. So x squared plus 2 would be the other factor. We could do the same thing kind of over here. Now with this one might be a little bit different. We would see that we have an x square, an x coming out of this, and so you have x plus 1 on this one. And actually it should be really, this one should move around. Put the x first on this one. This one, the x, y should be first and then the y. That way we would get the same matching binomial. So if I put the x out of this one, I'm going to get an x and then plus 1, because if I take the x out of here, there's still a 1, because 1 times, or x times x is x squared, and x times 1 is the x. So always remember you can multiply back in with the distributive property to check that. And then out of these two you can factor out the y, and then you still have an x here and then a 1 on this one. And then there's your matching binomial that we're going to look for in step number 3. Look for, factor out that matching binomial, that matching one. Let's move this out of the way a little. That matching one would be our answer right here. So the x plus 1 is one of the binomials in the answer, and then the other one is going to be from what we factored out. This would be a plus in between these two, so an x plus a y would be the other one. And that would be our answer right there. Alright, so let's go ahead and give you some more chances to practice this on the extra practice. Let's take a look at this. So on page 242, we'll look at 1 through 4 first here. So number 1, and again 1 through 5, it says we're going to be factoring by grouping when there is a positive in between the grouping. So 1 through 4 here, you can see that there's going to be a positive in between the grouping here. Basically, if the group here is, there's going to be a positive right here. But then there's going to be a few of them where we're going to see a negative, and that will be our next section. So number 1, we want to the first step now, remember, is to figure out how do we want to group these. We need to group them in 2 groups. So that's our first step. We're going to do the grouping step. So we're going to group this b to the third minus the 4b squared. Now this one only has b's in it. It's in standard form, b to the third, b squared, b, and 4. So the grouping was easy here. Just the first 2 can be one group, the second 2 can be the other group. So once we've grouped them, and notice we got this one here is a plus here. It's a plus, so we can see that when there's a plus there in between the groups in the 4 terms here, there's a plus right here. It's a little bit easier than when there's a minus. So the second step is now to do the factoring step. Factor out the GCF. So we want to factor out the GCF of each group. So from the first group, there's a b squared that can come out of this. But from the second group, there is nothing that can come out. So if there's nothing that can come out, then we would factor out a 1. So we still need to factor something out. It would still be just a 1 here on the second group. So we put the b squared out of the first group, and now we have a b minus 4, as you can see. From the second group, we said there was nothing we can factor out here. There is no GCF, no greatest common factor between these 2 terms. So that means we would just factor out a 1. We would put a 1 here, and then we still have the b minus 4. Okay, that's our second step. Our third step, once we've done our factoring out the GCF, is then to look for a matching binomial. And so between these two, there's a matching binomial of b minus 4. Now, what if it didn't match? If it didn't match, then this factoring by grouping would not be working. And it's possible that can happen sometimes, and we'd have to figure out another way to factor it or another way to work it out, or maybe it just is non-factorable. There are some polynomials that just cannot be factored. But this one, since there is a matching binomial, the factoring by grouping is working, and so that one can be one of the answers. So one of the binomials in the answer is that matching binomial, b minus 4. And then the other binomial comes from what was factored out. So the b squared plus the 1 goes in this other one, and that's what was factored out. Now, when you see a variable squared here, you want to be careful when you have a binomial and a variable squared, because you may end up having a difference of squares. That's our special binomial. The special 2-term one that you can factor is a difference of squares, and 1 is a perfect square. It's just this is not a difference. This is a sum. So we cannot factor that any further. But if this did say b squared minus 1, then we could factor that to 2 more binomials. So you got to be on the lookout for those as well. Now will definitely come into play when we're talking about factoring completely. Number 2, here's all letters here, so we want to see, okay, how should we, put this together? This one, the groups are already kind of set up. The first two can be grouped here with the A's. The second group can be grouped together because of the B's. And we can do now the second step here, which is the factoring out the GCF. In the first group, we're going to factor out A. In the second group, we're factoring out the B. So A comes out. Now you have an A plus D. And then this one, B comes out. Or not, sorry. If you factor out A, you have a C plus D. Factor out B, you have another C plus D. So the matching binomial here is the C plus D. You can see that matches, and that's why I underlined them there. So factoring by grouping is working. And so what we say here is the binomials must match for one factor. In order for the factoring by grouping to work, these binomials must be exactly the same. When you factor out that GCF, you must have a matching binomial, and that matching binomial is the first. You can put that as the first one in your answer. And then the second binomial, what got factored out comes together for the other factors. So what got factored out was the A and a B, so it's a plus B. A plus B is the other factor. And there it is. So it doesn't have to be very difficult or very hard to do. Our answer there is just those two binomials. Even the order doesn't have to be this order. We could be A plus B first, then C plus D second. All right, let's look at number 3, and then I'll have you try number 4 on your own. So for number 3, again, we got to group them first. And we got a D squared. Then we have 2C. Then we have a CD and a 2D. So we got to figure, okay, this doesn't look like the order is in the grouping order. And this looks a little mismatched. We have a couple 2's there. We'd probably want to put those together with the 2's. And so here's how we should group it. The D squared, the 2D, and actually I didn't group it with the 2's to factor out 2 on this one. I grouped it with the C's, this 2C and the CD, as you can see there. So I'm putting D squared and a 2D. That was that first one and the last one I put together. And then these two in the middle I'm putting together. And I'm putting it to where the 2's are at the end. Now there might be more than one way to group it and still get it correct. You could probably still group it by maybe factoring out the 2 and getting a C and a D, something like that, or a D and a C. But as you can see here, if I factor out the D on this one and factor out a C on this one, I'm getting a D plus a C, and then a D plus a 2 is the matching binomial. So as long as we get a matching binomial, you know it's working. And so your matching binomial, D plus 2, is one of your answers. And then the D plus C, or you could even say C plus D, could be the other one. And that would have been true. I could have also, I could have put these two together, and that would have worked also. And I would have factored still a D out of this one, and got a D plus C as well, and factored 2 out of this one, and I would have got a D plus C also. So that would have been a matching binomial, and then what I factored out would have been the D plus 2. So either way, as long as you get the matching binomial, you know you're working. Alright, so number 4, go ahead and pause the video and try number 4. This one is not necessarily going to be in order. You probably have to mix match. I would put the 5's together and the 6's together perhaps, and then factor out. So go ahead and try number 4. Figure out the grouping first, then factor out the GCF, and then look for a matching binomial to make your 2 binomials. So pause the video and do number 4. Alright, so hopefully you finished number 4. You have 2 binomials as an answer. Let's see if you maybe group them. Let's see if you get the right 2 binomials first. So our answer should be a t, we're in variable is t here, t squared plus 1, and a 5t plus 6. Now the order doesn't matter. You could have had this one first, and then t squared plus 1 second. So if you got those right, then you did it correctly up here with grouping. If you didn't get your answer right, let's see if you can figure out maybe what we did here. I grouped the ones with the 5's together, and then I grouped the ones with the 6's together. That way I can factor out a 5t. That would be our GCF of this one, because there's a t in both of these. So 5t can come out. This one, just the 6 comes out. And so when I factor out 5t, I'm going to get the t squared plus 1. When I factor out the 6, I'm going to get a t squared plus 1 as well. The matching binomial on this one is t squared plus 1. And then what got factored out was 5t plus a 6, and that's my other binomial. All right, let's move on to number 5. So number 5 is still another one where we're going to see there's going to be a plus in between of our groups. So when you look at the plus in between the groups, so I match up the groups here with the, because this right now you just have s's and it's not in standard form. If we were to put this in standard form, it would be this one, then minus 64s squared, then plus s, and then minus 8. So that's why there's still a plus in between the groups. So I'd group these two together and group these two together. So I'm factoring out an 8, because 8 can come out of 64, and an s squared. From this group, there is no GCF, so we will factor out just a 1. So 8s squared from the first group, leaving me with s minus 8. Factoring out a 1, I still have my s minus 8. And that s minus 8 is the matching binomial that I will put right here. So s minus 8 could go first. What I factored out was 8s squared plus the 1. And again, I want to look for a possible difference of squares. This is not a difference of squares. 8's not even a perfect square, so I couldn't factor this one anymore. All right, let's take a look now. 6, 7, and 8. From 6 through 8 here, it says where there is, we're going to factor by grouping, where there is a negative in between the grouping. So for number 6, a to the third, a squared, a, and a 5. So the grouping would be the first two, grouping is the second two, but there's a minus in between. We have the same thing happening here on number 7, same thing happening here on number 8. There's a minus in between the two groups. Okay, so we're going to still, all the process, those 3 steps are still the same. We just have to work with a minus here in between the two groups. So the first thing is to group the first two, to put the grouping out. So I'm grouping the first two, and I'm going to group the second two. Now when I group them, I'm going to group the negative in the group and then put a plus still in between the groups. That I think is going to be the most helpful thing. So when you group them, just still put a plus in between the two groups. So you have the minus 30, so the 30a is negative. Make sure it stays negative in your group with the minus 5. And so now when we want to factor out our GCF from the first group, we're going to factor out a 2 and an a squared. But when we factor out the GCF as well here, we're going to factor out a negative along with any other GCF number. So in this case, 5 can come out of 30, so 5 is going to come out as a GCF, but it's going to be a negative 5. We want to factor out a negative because we want this first term to be positive. So when I do that, I'm factoring out the 2a squared. I'm going to get 6a plus 1. When I factor out negative 5, so now at this point the plus will kind of go away because positive times negative will be negative. So my negative 5 is out. That changes the sign here to a positive, and a 6a changes the sign here to a positive, and it's a 1. And now there's your matching binomial is 6a plus 1. So don't forget, what we want to make sure we do here is factor out the negative. So I'm factoring out the negative as well from both terms. That means it's going to change the signs of both of these terms here when I factor out a negative. This term becomes positive, this term becomes positive. And we're factoring out a 5 as well, so we're dividing 30 by 5 to give us 6. 5 divided by 5 gives us 1. And there's our matching binomial. That can go up front, 6a plus 1. What got factored out is 2a squared minus a 5. Again, this you can check it to see if it's a difference of squares. It's not, so it can't be factored any further. All right, I'm going to have you try number 7 on your own. But let's do number 8 first, and then you can go back and do number 7. So let's look at number 8 right now. So I'm going to see our groups are already kind of set up with the first 2 and the second 2 here. So that's our groups, but I'm going to put a plus in between the groups. So it's going to be our first group, then the plus, and then this grouping starts with the negative, negative 35h, then minus 30. I'm going to factor out the GCF here between 21 and 18. 3 can go into both of those, and there's also an h squared that can come out. So 3h squared. From this one, a 5 can come out of both of these, 30 and 35. as well as a negative. So another negative 5 is going to come out of here. So it's a 3h squared from our first group. When I divide each of these, this is going to be taking 2 h's away, so there's 1 h left. 21 divided by 3 is 7. So 7h. Both h's come out, and 18 divided by 3 is just the 6. So we get 7h plus 6. When I do factor out a negative 5, it's going to change the sign of both of these. They're both negative here, so they're both going to be positive. And then divide by 5. 35 divided by 5 is 7, so 7h there. 30 divided by 5 is 6 here. So another 7h plus 6, there's our matching binomial. And then what got factored out, the 3h plus 3h squared minus 5 is the other binomial. So there's our two binomials for the answers. And this is not a difference of squares. We can't factor it anymore. So we just stop right there. There's our answer. All right, so number 7, I'm going to have you try 7. Do the same thing on 7 as we were just doing on 6 and 8. So go ahead and pause the video, do 7, and then play it to check your answer. All right, so here, let's check your answer for number 7. I'll show you the answer you should have got. An x minus 3 binomial and a 4x squared minus 5 binomial. It doesn't have to be in that order, but those are the two binomials that you should have for an answer. And if you didn't get that right, let's go and see if you can figure out maybe what you did wrong. Again, we're grouping them just with the first two here in the first group, second two here, but I'm going to put a plus in between the groups. And then factor out GCF. So from here, we're factoring out a 4 and an x squared. From this one, again, we're going to factor out a negative, because it's the negative in front here. From 5 and 15, also 5 as well comes out of that. So we factor out negative 5 on every single one of these. So when you factor out the 4x squared, you're left with an x minus 3 from this binomial when you divide by 4. 4 divided by 4 is 1, 12 divided by 4 is 3, and then you take 2 x's out of those. Divide by 5 here, you're going to get a negative. You're going to get now changing the signs. This is positive, this is going to be a negative. 5 divided by 5 is a 1, 15 divided by 5 is 3. So matching binomial is your x minus 3, what got factored out, 4x squared, minus 5 goes in the other binomial. Alright, so hopefully you were able to get that correct. That's factoring by grouping. We took that when it was a positive in between the groups, and when it's a negative, it's a little more difficult, but not too much. Alright, let's take a look at our joke of the day, and then we'll go on to factoring completely. So our joke is, why are teddy bears never hungry? Why are teddy bears never hungry? Well, because they're always stuffed. Always stuffed. Well, that's why. Yeah, they're full of stuffing. That's why they can't ever be hungry. All right. Well, let's move on. Factoring polynomials completely. So we've seen how we can factor binomials. The special binomial is like this right here, which is called a difference of two squares. X squared minus 1 can be factored in this form where you have an x plus 1, x minus 1. 1 plus, 1 minus. You're going to break apart the x squared to two x's there. The 1 is always the same number because you're looking for a perfect square, which is always a number times itself. But we also seen a couple like this. When there's an x squared plus 1, that can't be factored any further. You're done. That's as far as you can factor that. So it can't be factored anymore. So this polynomial is unfactorable when it's like that. So basically, how do you know when it's factored completely? It says a factorable polynomial with an integer coefficient is factored completely when it is right here. And this is what you want to write down for your vocabulary word on 241. Factoring completely is when as a product of unfactorable polynomials with integer coefficients. When it is written as a product is where you have all these parentheses out, and every parenthesis is unfactorable. You can't factor any of those any further. If you can still factor what's inside of a parenthesis further, it's not factored completely. So what we need to do is we need to first, here's our guidelines for factoring completely, this concept summary. Number 1, we want to first make sure as we're factoring, the first thing we do is look for a GCF. And I wrote these on the side here. You probably want to write these on the side too. Don't write these next to this. Number 1, factor out the greatest common factor. That's the first thing you look for. I always say, this is what we need to look for when we're going to go to factoring. Look for the GCF first. If there's a GCF, that needs to be factored out. Then, second thing is look for a difference of two squares. Is there a binomial? If there's a binomial, look for a difference of two squares. Now, you might have a perfect square trinomial like this is showing right here that can be factored to a binomial squared. That's possible. But you could always deal with trinomials when we come down here and you're looking for the trinomials. That's really kind of number 3, is you're looking for, okay, if it's a trinomial, see if you can factor it either with the simple method or with the star method. And in this case, they put it like this. This was actually a typo right here. They should have had a 3 in front of this x squared. You want to fill that in there. There should be a 3x squared in order to have the 3 right there. So they made a mistake as you were writing this down or printing this out. So number 1, look for GCF. Number 2, if you see a binomial, especially difference of two squares, look for those special binomials. Difference of two squares is the special binomials. And then you want to look for any trinomials. You might have a perfect square trinomial, and that could be factored like this. You might have a trinomial that would just need to be factored with the simple method. Or you might have a trinomial that needs to be factored with a star method, and you would need to factor it like this one here to two binomials. Number 4 is you want to see, okay, if it's got 4 terms, then you want to see can it be factored by grouping. And here's what we'd see factoring by grouping. We want to do the groups here. That's what we want to do. And so I say over here is look for standard form. You want to see it should be in standard form. Make sure your trinomial is in standard form. Your factored by grouping, your 4 terms is in standard form. And that way you can then try to factor it with either, trinomial would be star method or simple method. And then if it's got 4 terms, factor it by grouping. All right, so that's what we're going to go into now in our extra practice. Is 9 through 14. We'll look at these first. Now I wrote over here on the side, and this is what you want to write here, is on this section, fully factored is the goal. We want to be fully factored. That's what we're trying to do. So I'm going to have you do the highlighted ones on your own, but let's come through and do 10, 12, and 14 together, and then you can go back and try these highlighted ones on your own. So number 10 has 2 terms, but the first thing we want to look for, number 1, is GCF. We're looking for a GCF to factor out, and this one does have a GCF. So number 1, we're going to factor out the GCF. It's always the first thing. And the GCF between these two, there's definitely an x squared that can come out and 25. So 25x squared comes out, and then we have a 4x squared minus 1. And so now what we see is, since there's 2 terms, we want to see, is it a special binomial? And that is a special binomial. It is a difference of 2 squares. So that's what we want to see. Number 2, we're looking for special binomial. So the special binomial is that it's a difference of 2 squares. So we can factor this to a 2x up front, and then 1 is just 1 times 1 with a plus and a minus. 1's plus, 1's minus, and there it's factored. And so there it is. Fully factored was our goal. We got it fully factored now. So we got the GCF outside of it, and then our 2 binomials from the factoring the difference of 2 squares. So don't forget to keep your GCF still always in your answer. Okay, number 12. Let's try number 12. It's a trinomial, and is it in standard form? We can see, yeah, it's in standard form. So in this case, there is no GCF. We're going to have to be doing the star method for this. So we'll need to use the star method to be able to do this one. There is no GCF. It's got a 9 in front, so it's going to require the star method for a trinomial. So as we do the star method, we multiply 9 times 14 on the top. The 3 would go at the bottom of the star. That's where we start this. So 9 times negative 14 is negative 126. Positive 3 goes down at the bottom there. And then 9x and 9x, that's how this starts. That would go up on top. Now we're looking to figure out what 2 numbers would have multiplied to give us 126. That would subtract to give us 3. So obviously 9 times 14 is 126, but they don't subtract to give you 3. They would subtract and they would give you a 5. So it's kind of close, but it's not the right thing. So what we want to do is figure out what's all the factors for 126. And I wrote them over here. So you can see 1 and 126, 2 and 63, 2 times 63 is 126, 3 times 42, 6 times 21, 7 times 18, 9 times 14. Those are all the ways you can multiply two numbers and get a 126, but if we look through all these, you cannot subtract any of them and get a 3. Like I said, this would give you a 5. This one here is going to give you an 11. It's just not going to work. There's nothing here that's going to work and give us a 3. So if that's true, then that means that this trinomial right here is already fully factored. It's unfactorable. It's an unfactorable trinomial. So there's no way to factor that. And you might come across some that are unfactorable, but very rare. These are going to be the rare ones. Most all of the ones we're going to do are going to be factorable. But there is some times when it could be unfactorable. Let's look at number 14. Another trinomial. Again, first thing we want to look for is GCF, and there is one right here. They're all even, 12, 20, and 48, so 2 can come out. But even bigger, 4 can go into all of these numbers as well. 4 goes into 12, 20, and 48, so 4 can come out. So we want to factor out a 4. GCF is the greatest common factor, not just a common factor, but the greatest one. So when you divide everything here by 4, you get 3x squared minus 5x minus 12, and now you have a trinomial, and so again we're going to have to use a star method from this trinomial because it's got a 3 in front of the x squared. So again, 3 times negative 12 is negative 36 on top. Negative 5 is going to go at the bottom of the star. And then the way this begins is 3x, that goes at the top of each side. And so when we ask ourselves what multiplies to give us 36, that subtracts to give us 5, that would be a 9 and 4. 9 times 4 is 36, and 9 minus 4 is 5. We know they're different signs. The bigger number 9 is going to get the sign of the 5. So 9 is negative, and the 4 is positive. And now we want to see, as each of these sides simplified, 3 over 4 is simplified, but 3 over 9 is not. So I can reduce this by 3 to get a 1x over a negative 3. And so now these are my two binomials here. So one is going to be 3x plus 4 from this side. The other one's x minus 3 from this side. And now that is fully factored. There, you can't factor those two binomials any further than that. And in fact, I actually made a mistake right here, didn't I? I told you right up here, don't lose your GCF, and I lost my GCF right here. There should be, I'll put this in red here, there should be the 4 still up in front there. So make sure you do that. Don't lose that GCF. It should be 4 in front of those two binomials. It's easy to do that, especially when you do the star method, because you get so involved in that that you forget about, wait a minute, I factored a 4 out first. I got to have that in my answer. So 4 is there in front of those two binomials. All right, go ahead and try 9, 11, and 13 on your own. Again, you're going to have to probably use some star methods here on a couple of them, maybe one of them at least, I know. So star method on one, difference of two squares on another one. So do 9, 11, and 13, and then check your answers by playing the video again. All right, let's go ahead and check your answers. Hopefully you have 9, 11, and 13 all complete. And let's see if you did these correctly. So starting with number 9, we would start by factoring out the GCF. There's a 4 and a c. 4c comes out. And now you got c squared minus 4. And that is a special binomial. That's the number 2. There's a difference of squares there, a special binomial that you can factor with a c squared minus 4. So you need to make sure you can recognize that is a special one, because it's a difference of two squares. So that can factor to c and a 2. So c plus 2, c minus 2. So again, we're not losing our 4c. 4c stays in front. c plus 2, c minus 2. That is now fully factored. Number 11. This one I don't see a GCF. So in this one we're just going to be using star method. That's how we would do this one. So 2 times negative 2 is negative 4 on top with a positive 3 on the bottom. And the way this begins is 2a on the top of each side. Two numbers that multiply to give me 4, that subtract to give me 3 would be a 4 and a 1. They are different signs. The bigger one, 4, is going to be positive from the 3, which means 1's negative. 2 over 1 is simplified, but 2 over 4 is not. So I can reduce this by 2 here, so I'm going to get this to become just an a on top. 2 goes into 2 once, so just 1a, and 2 goes into 4 2 times, so positive 2. So there's our one binomial, 2a minus 1 and a over a plus 2 on the other one. So that one, they didn't have it. There was no GCF to put in front of this one. It's just those two binomials, and now that is fully factored. For number 13, this one does have a GCF because they're all even numbers. So we definitely know there's a GCF here, 20, 22, and 12. We can definitely factor 2 out of this one, and that's what we would do factor. That is the greatest common factor, is just the 2. So divide everything here by 2, you're getting 10p squared, 11p, and then a minus 6. And with the 10 up front, we're going to need to use the star on this one as well. So with 10p squared, 10 times negative 6 is going to be negative 60 on the top, and then the 11 is going to be on the bottom. So negative 60 and 11. The 10p is the way this begins, 10p, 10p. And so then we're looking for two numbers that multiply to give us 60, that would subtract to give us an 11, and that's 15 times 4. 15 times 4 is 60, and 15 minus 4 is an 11. And so that's going to be different signs. The bigger one, 15, is going to get the sign of 11, so 15 is a positive, 4 is negative. Now both sides need to be reduced. This one can be reduced by 2. So 2 goes into 10p, it becomes a 5p. 2 goes into negative 4, it becomes negative 2. So 5p and over a negative 2. This one, 5 can go into both of these. So 5 goes into 10 2 times, so 2p on top. 5 goes into 15 3 times, so positive 3 on the bottom. And so now we see our two binomials there. We got this one, 5p minus 2 and 2p plus 3. And do you notice a mistake that I made? Hopefully you're noticing a mistake. What mistake has been made? I did not remember that there was a 2 originally factored out. I forgot it. I did the same thing as I did on 14. I need to make sure I put a 2 in front of this. 2 in front of those two binomials is their actual final answer. That would not be fully factored if I forget the 2. Fully factored now is with the 2 in front of this. So hopefully that you didn't make that same mistake that I did. But it's easy to make that mistake. As you can see, I did it myself when I was originally doing this. All right, let's go on to number 15 in that section. Number 15 and 16, here what we see on 15 and 16 are 4 terms. So we see 4-term polynomials. I'm going to do 16, and then I'll have you try 15 on your own. So you can see here we're going to factor by grouping. There is no GCF. We'd want to look for a GCF first, but there is no GCF between the 4 terms. So it's just going to be a grouping one. And they are in order with T's here. It's in standard form with descending order. So we're grouping the first 2 together. And then it's got a minus here with the 10. So we're going to put the 10 in this group here and put the plus in between like I showed you earlier. From this group, we're going to factor out a t to the 3rd power. And from this group, we're going to factor out a negative 5 again. We like factoring out negative 5s here. So t to the 3rd comes out, and now it's a 2t plus 1 from this group. Negative 5 comes out, so we change both signs, and now it's a 2t plus 1 from that group. There's our matching binomial. And what we factored out was t to the 3rd minus 5. So 2t plus 1 is in one binomial, t to the 3rd minus 5 is in the other binomial, and now that is fully factored. So that was just like we were doing earlier on the groupings before. So try 15 on your own. Another grouping one, just factor by grouping, and then play the video to see if you get the right answer. All right, so hopefully you have an answer for this one. So we are factoring by grouping, and it is grouped in descending order here. So the first 2 and the second 2. So the first 2 group, we do have a negative again with in front of 21. So that's one negative is going to go with 21 in the second group here. Put a plus in between. And then when we factor out just s squared from the first group, and then this one we're going to factor out the negative. So that will change the positive to a minus. And factor out a 7 between 14 and 21. So s squared comes out of this one, it's 3s plus 2. Negative 7 comes out of these two, so basically divide both by negative 7. That gives us a positive 3s. Divide here by negative 7, it's a positive 2. So your matching binomial there is 3s plus 2. What got factored out was an s squared minus 7. So there's your two binomials. You just want to look at this one and just see, okay, is it a difference of 2 squares? 7's not a perfect square number, so it's not, and that can't factor anymore. So it's not a special binomial because of the 7. 7 is not a perfect square number. So that is fully factored with just the two binomials. Alright, so number 17, and then going on to our last section here for this lesson, 17 to 22. So 17 to 22, it says we're going to solve the equation. So now what we have is a equal sign in our problem. It's not just an expression, it's now an equation. When there's no equal sign, we call it an expression, and we can factor expressions. But when it's an equation, we can solve it by factoring, and so that's what we're going to do here. But in order to solve by factoring, the first thing we have to do, and I wrote the steps over here, first thing is to make sure it's in standard form. It has to be standard form equal to 0. So, and you can see the top 3, and even number 21, is in standard form. So that's already done for us pretty much. So standard form is done there. And then we want to factor fully. That's the next thing to do. After we factor fully, then we want to use the zero product property, which means set each factor equal to 0 separately. And then the last thing to do is solve each equation. All right, so I'm going to have you do the highlighted ones on your own, but let's do 17, 21, and 22 first. So starting with 17, is it in standard form? Yes, and I put it just a check for that one. Yes, it's standard form. So now we just need to go here to number 2, factor fully. So what do we need to do to factor it? We need to first make sure we factor out a GCF if there is one, which there is. 3 can go into all 3 of these. So we could factor out a GCF of 3. Divide each of these by 3. So that's going to give us an x squared, negative 7x, and then a 10. The next thing we want to look for is this trinomial. Can we factor the trinomial to 2 binomials? And we can with a simple method, just has an x squared here. So 3 is going to continue to stay out in front. And then we put x and x in front of these, 2 numbers that multiply to give me 10, that add to give me 7 is a 5 and a 2. 5 times 2 is 10, and 5 plus 2 is the 7. Remember, we're adding because it's a positive 10 here in the back. And this positive tells us that the signs in here have to be the same sign. They're both going to be the sign of the 7, so they're both going to be negative. And you can always double check that by just doing FOIL to get back to this trinomial. You know, your x times x is x squared, your outside is negative 2x, your inside is negative 5x. That would give you a negative 7x when we combine. Negative 5, negative 2 is the positive 10. So now that's factored fully there. What we need to do is go on to the next step here I have in green, zero product property. So we're going to set each factor. Now I'm only going to set the factors equal to 0 that have a variable in them. Since the 3 has no variable, then I can basically forget about that 3 that's in front here and just focus on the factors that have a variable. So I'm just going to be setting x minus 5 equal to 0 and x minus 2 equal to 0, those 2 factors. And now I can go on to number 4 and solve each simple equation here by adding 5 here, adding 2 here. And so my answer is just going to be x is positive 5, x is positive 2. There are 2 answers, one from each of those. And that's kind of a clue. When you have an x squared, there's a possibility of getting 2 answers. Most likely you'll get 2 answers if it's x squared. It's not a guarantee, but you most likely will get 2 answers. All right, so let's go on to 21. 21, starting with standard form. Is it in standard form? It's equal to 0, so that is standard form. So check for that. We want to then factor fully. Is there a GCF? There is between here. A 3 can go into 48 and an n's in both of these. So we'll factor out a 3n. That will leave us with a 16 minus n. So when I divide this by 3n, I get a 16. When I divide here by 3n, I just get 1n here. And there's a minus in between. And so now I'm going to go on to my third step. So now it's factored fully here. This is completely factored. Zero product property is next. And since the GCF has a variable, we're going to set that equal to 0 and this other factor equal to 0. So set the factors that have the variables equal to 0. In this case, both of them do. So 3n equals 0 and 16 minus n equals 0. So from this one, if you have a monomial, your GCF factor is equal to 0, that's definitely going to be 0 for n. This one, I could add the n to both sides, and then n is just 16. So n is going to be 0 from this one, and n is going to be 16. You can actually plug this in. 0 goes in for n. 3 times 0 is 0, and that works. 16 goes in here for n. 16 minus 16 is 0, and that works also. So there's my two answers, 0 and a 16. Okay, number 22, starting with standard form. This one is not in standard form. So what we need to do is make sure it's set equal to 0, and I want to move these two over to this side since this is where my highest term, which would be x to the third, that would be the leading term here, is positive. We want that leading term to be positive. So I want to move these two to this side. So I'm going to subtract 16x, and I'm going to subtract 48. And so that's now going to give me the x to the third plus the 3x squared, then minus 16x minus 48, and it's going to be equal 0. So now that's our standard form that I want to see. So now that I'm in standard form, I can then go on to fully factoring this, and I'm looking for a GCF. There is no GCF between the four terms, but it is got four terms, so we're going to factor by grouping. And we're going to group the first two and group the second two. When I group these first two, we're going to factor out just an x squared from this group, leaving us with an x plus 3. That's what I'm getting here. If I divide each of these by x squared, take two x's out of this one, take the x squared, we still have the 3 there. From the second group, it's got the negative, so I need to factor out a negative and a 16. 16 does go into 48 3 times. And you're trying to look for a matching binomial, so that might be a clue if you see you have a 3 here. Well, 16 times 3 is the 48. So you're going to factor out a negative along with this. So the negative 16 comes out. So divide each of these by negative 16. That leaves you with an x and a positive 3. And then there's your matching binomial. So the x plus 3 and an x squared minus 16. So x plus 3, x squared minus 16. And that x squared minus 16, you want to make sure always look out for special binomials with the x squareds. That is a special one. It is a difference of two squares. So this can be factored to two more binomials. So it's not fully factored yet with this. We need to factor one more time for it to be fully factored. So I still have my x plus 3 here, but then this can become x plus 4, x minus 4. So you have your x squared is the x and the x. 16 is 4 times 4, 1 plus 1 minus. And now that is fully factored. So now we would go on to the zero product property and set each one with the x, since all three of them have an x. Each one's going to get set equal to 0. X plus 3 equals 0, x plus 4 equals 0, x minus 4 equals 0. And then we would just solve this. So you'd subtract 3 on this one, getting x equals negative 3. Subtract 4 here, x equals negative 4. And add 4 on this one to solve, x equals positive 4. So there's our three answers. X equals negative 3, x equals negative 4, x equals positive 4. Notice the degree of this polynomial is a 3. So the degree of your polynomial tells you how many possible answers you're going to have for x you might have. So since this one had x to the third power, then it's a possibility we could get 3 answers for x. We might not get 3 answers for x. We might only get 2, we might only get 1, it's possible. Or we might not have no solutions, perhaps. But in this case, we had 3. Alright, so I'm going to give you a chance here to try 18, 19, and 20. So go ahead and pause the video and try to solve 18, 19, and 20 for the variables that are there. And then play the video just to check those last three answers. Alright, so hopefully you have those 3 done, and now let's just check to see if you did those correctly. I like to give you chances to try these on your own and practice these on your own. You need to try these on your own to see if you can do these on your own and not just copy it down from me. So number 18, it is in standard form. Check. Okay, it's already in standard form on this one. I said that earlier. It's equal to 0. So we just need to factor out a GCF here. When we factor out a 5, we're going to be left with a y squared minus a y minus 6. And then that trinomial can factor to 2 more binomials with the simple method. So 5 stays out in front here. Y and y is from the y squared. 2 numbers that multiply to give us 6 is 3 and 2. And they also have to be able to subtract to give us a 1. 3 minus 2 does give us 1. They are going to be different signs. The bigger one, 3, is going to get the sign of the y. So that's a negative. That way when you're doing the outside, you're going to get positive 2y. Inside's negative 3y. So combining those would give you a negative 1y here for the middle. And then the last terms would give you the negative 6 when you multiply. Zero product property, since this 5 has no variable, we don't need to worry about that anymore. It's just y minus 3 equals 0, y plus 2. So your answers there would be 3 and a negative 2. You'll add 3 on this one to get y equals 3, subtract 2 here. Number 19, already in standard form, check, so you didn't have to do anything there. But we can factor out a c squared from this. C squared is going to come out, and then what's left would be a c squared minus 81, and that is a special binomial. 81 is 9 times 9. So it is a difference of 2 squares. C squared stays still out in front, and this becomes c plus 9, c minus 9. So the c and the c goes up front, 9 and 9 go in the back, 1 plus 1 minus. And now with the zero product property, since your GCF does have a variable, you're going to set each of these. Now this one's got a 4 here. Your highest degree is 4. We could possibly have 4 answers for C, but actually we actually don't. We only have 3, as you can see here. We're going to see c squared is equal to 0, and then you have c plus 9 equal to 0, c minus 9 equal to 0. So from this one, you're going to get 0. So c is going to equal 0 from this one. Subtract 9, you get negative 9 from this one. Add 9, you get positive 9 here. So you really only get 3 different answers for C. 0, negative 9, and a positive 9. But on this one, there's actually 2 that have a 0. We would actually call this kind of a double answer or a double root, they might say. So this one actually has a repeating kind of solution here with the 0. But we only need to say it once. All right, coming to number 20. You can see now this one is not in standard form, and you want to move, so you can see where the d to the third is here. That's positive here. You want to move these two this way. So you're going to subtract 9d, you're going to subtract 9 first. So that's the first thing to do, is to get it in standard form. Subtract those, and so now you're going to start with d to the third, then plus d squared, then minus 9d, then minus 9, and then you could say equals 0. So all of that, there's your standard form, equal to 0. So we're factoring here with the grouping. Grouping these first two, we're going to factor out d squared. Grouping these second two, we're going to factor out a negative 9, since this one's a negative in front of that middle term. So d squared comes out, we're left with d plus 1. And then negative 9 comes out, we're left again with d plus 1. So there's the matching binomial, so grouping is working here. So d plus 1, and then you're going to have a d squared minus 9. But again, look at that d squared minus 9. 9 is 3 times 3. It's a perfect square number. So we can factor this one more time, just like we saw over here with x squared minus 16. So this can be d plus 1 first, and then this factors to 2 more binomials with d plus 3, d minus 3. Now it's fully factored. And so now we can set each factor equal to 0. I put that over here with the zero product property. D plus 1 equals 0, D plus 3 equals 0, D minus 3 equaling 0. So you're going to subtract 1, and then you're going to subtract 3, and then you're going to add 3. So your 3 answers for this one, D is going to equal negative 1, negative 3, and a positive 3. All right, so hopefully you're able to get those answers right, and you're verifying that you were able to do that correctly. And if you didn't do it correctly, if you got something wrong, you can check your work here, check the work with what I did, and just see if you can figure out what you made a mistake with, and then always just fix that on your notes. You want to always make sure your notes are correct, so whenever you look back at your notes, it is going to be correct. All right, so that concludes our lesson here on 7.8, and actually it concludes Chapter 7. So I won't see you again until Chapter 8, so have a great day, and I'll see you when we start on Chapter 8. Take care.